All right, guys, today we're going to talk about special line segments of triangles. Okay, we're going to complete the following. We're going to complete the following definitions using the following words: vertex, midpoint, perpendicular, angle, and ray. A vertex is a specific point. The midpoint is in the middle. Perpendicular creates 90 degrees or right angles. An angle is two rays together, and a ray is a single line. Alrighty, so the median is a line segment between a blank and the blank of the opposite side. Starts at a vertex, goes to the midpoint of the opposite side. So maybe we're going to use the word midpoint. The midpoint's going to go in this one. So it's a line segment between, it starts at a vertex and goes to the midpoint. So it's between a something and the blank. Well, I see the word vertex, so I think I'm going to take that one too. So vertex and midpoint. Between a midpoint and the vertex of the opposite side. Can a side have a vertex? No. So between a vertex and the midpoint of the opposite side. Altitude is a line segment through a blank and is blank the opposite side. Starts at a vertex, intersects the opposite side, they're the right angle, and I see the word perpendicular in parentheses. It's a line segment through a blank vertex and is perpendicular to the opposite side. An angled bisector is a blank, the cuts and blank in half. I think that's supposed to say that. That is supposed to say that, not the. An angled bisector is a blank that cuts an blank in half. It's really hard to say "an" in front of the word blank. So angled bisector starts on a side, goes the opposite angle, bisects the opposite angle in two congruent angles. Well, he's a ray because he's kind of like a line, but he's not a full line. And he cuts an angle in half. Perpendicular bisector is a line segment that contains the blank and is blank to the other side. Starts on a side, intersects opposite side at its midpoint, forming right angles, divides opposite sides into two congruent. I see the word right angles, so I'm going to say perpendicular is going to be one of them. And it has a midpoint, so maybe midpoint is going to be another one. Perpendicular bisector is a line segment that contains the midpoint and is perpendicular to the side. Woot, woot. Gonna make sure, okay. Complete the following statements. If AC is the perpendicular bisector, then the measure at ACB is what? What does it mean to be a perpendicular bisector? Starts the side, intersects opposite sides, forming right angles. Oh, I'm sorry, did I say that too loud? So it creates a right angle, so that means that this guy is 90 degrees. Okay, if AC is a median, then BC is equal to median. Starts at a vertex, goes to the midpoint, divides the opposite side into two congruent segments. So, if it's the median, then BC is equal to CD. I'm sorry, DC. I need to keep my spots congruent. All right, let's keep going. If AC is a median, then the point C is what? So it goes, starts at a vertex, goes to the midpoint of the opposite side. Is an angle A opposite of BD? So this one is midpoint. If AC is an angle bisector, then angle BAC is congruent to, what does the word bisector mean? We have seen this word. Oh, stops being see-through after a while. Right there. Two congruent angles. So BAC, DAC. We have to go in order, remember. All right, if AC is an alternate, is an altitude, then the measure of angle ACB, well, let's go figure out what an altitude is. All right, it's gonna be in the way either way. I'm trying to figure out where to put my videos so that I'm not in the way, but I don't really have a good spot. Starts at a vertex, intersects the opposite side at a right angle, creating something that we like to call perpendicular. Perpendicular means what? Right angle's good. So then if it's an altitude, then the measure of ACB is 90 degrees. If AC is perpendicular bisector, then BC is equal to, well, perpendicular bisector cuts it in half. That word bisector, this is the one I'm looking for, two congruent segments. So then BC is equal to CD. Next picture. I should have 4 total. If P is the circumcenter, then AE, okay, there's lots of lines here, so I'm going to highlight as we go, A to E. Oof, that wasn't the straightest, sorry guys. If P is the circumcenter, so what's the circumcenter mean? Well, I'm not seeing it pop out as one of my big titles, right? So now we're going to have to dive in and look for the word circumcenter. Hey, look, center right here, circumcenter. Do I see the word circumcenter? Nope, I see incenter. Centroid. Orthocenter. Still not circumcenter, okay? So that's the only one with circumcenter. So what does it keep saying? If P is a circumcenter of AE, I'm sorry, if P is a circumcenter, then AC is a, going backwards, it's going to be a perpendicular bisector. And I am going to type that one. All right, let's undo that highlight. Look at the next one. If P is the incenter, oop, there it is. Then AE is considered a, where's my mouse? Mousey, there. If he's an incenter, then it's an angle bisector. Sorry, I could not get my E in there to save my life. If P is a centroid, okay, let's look for the word centroid. Says if P is a centroid, then AE is the median. And orthocenter. Please, yellow. Nope. And it says if P is an orthocenter, then AE is it's got to be the altitude. Okay. Purple. If AP is equal to BP, then P is okay. Starts at the side, intersects the opposite side, divides opposite side into two. Circumcenter is equidistant. Equidistant from each vertex. Well, A is a vertex, B is a vertex. They're both the same distance, right? AP equals BP. Ooh, so that could be an idea. That could be maybe a star. Starts at the side, goes to the opposite side, bisects the opposite angle into two congruent angles. I don't have anything with angles, so I don't really care about a bisector. Median. Midpoint on the opposite side, divides opposite side into two congruent segments. Centroid is 2/3 the distance. Nope, I have equal distance. Altitude starts at a vertex, intersects the side. Altitude is inside, outside, the leg, and outside. It doesn't matter at all. So it has to be perpendicular bisector. So it bisects it, so then he's the circumcenter. And because the world hates math and never knows any math vocabulary. Okay, new one. If DP is equal to EP, then P is okay, well, it can't be perpendicular bisector because we just had that one. Starts on the side, goes to the opposite angle, bisects the opposite angle into two congruent parts, equidistant from each side. D hits at a side, E hits at a side. They're the same distance. Okay, so it could be that one. 2/3 the distance, nope, we're equal, and then meets outside. It's got to be angle bisector. So if it's angle bisector, it's called the incenter because we're talking about P. Okay, let's clear this. If BP equals 2/3, hey, wait a minute, something was 2/3, it's got to be the centroid. Boom. Process of elimination right there. Oops. Still tells me it's wrong, but I promise you I'm reading it off the paper and that's how it's spelled. The world hates math. It doesn't like to recognize math terminology. Whoa, why is this so far down? Okay. I don't know what happened to my picture. It didn't get fixed. Well then. All right, complete the following statement. If AC is perpendicular bisector, then BC is equal to, remember that word bisect, cut in half, so CD. I don't know why this one looks so strange. Going counterclockwise because math is weird. If AC is the median, then the point C is the blank of BD. If it's median, it's the midpoint. If CAC is an angle bisector, then it does something to the angle. Well, it cuts it in half, so BAC is equal to DAC. If AC is perpendicular bisector, then ABC is equal to, I just did that one, but it's actually also equal to 90 degrees. If AC is an altitude, then angle ACB is also 90 degrees. And if AC is a median, then BC is equal to CD. If P is a circumcenter, then AE is a blank. Circumcenter deals something with a cutting, angles, called a perpendicular bisector. If P is an orthocenter, then AE is an altitude. If P is the incenter, then AE is the angle bisector. And if P is the centroid, then AE is the median. For some reason I thought I had you do this other stuff as homework, but maybe we did it together. Okay, this must be the, I'm sorry, I thought this, part of this was notes, part of this was homework. Go get a, pause video, and you need to get the following colors: blue, green, red, and yellow. So go get blue, green, red, and yellow. I'm gonna try and do the highlighter so we can see it. So this will be my yellow. This will be my green. This is really hard to do with your mouse. Here's my yellow. Here's my green. Here's my blue. I'm gonna do pink as red, only because I don't have a red highlighter. Oh, I might be able to get a red highlighter. I just don't know what it's gonna look like. Let me try that. I'll try the red and see what it looks like. Okay, it works. All right, so an altitude is blue. Altitudes have right angles, and it needs to be the entire length. And so my right angle, or my altitude, is from A to C. My angle bisector has got to cut an angle in half, and the only angle I see cut in half is angle C. So CD must be the angle bisector. The median goes from an angle to the side, and it cuts that side in half. So the only other angle that's getting cut is here. And then my perpendicular bisector sorry, I'm trying to see so you can see the rest of E. I don't know. I'll keep it red. And then my perpendicular bisector goes from a side to another side and creates a 90-degree angle. Okay, number 2, altitude. I see I have 2 different right angles, but I need to go from a side to an angle, I'm sorry, from a side to a vertex, and if I notice FB doesn't go to a vertex, so it's got to be EB. Angle cut in half, the only one cut in half is A, so that should be pretty easy to see. Perpendicular, I'm going to go and do the perpendicular bisector. I'm going to go out of order. Perpendicular bisector, equal guys, equal sides. So if you notice A to F and E to F are equal, so it's got to be here. And then my median goes from an angle to the center of the other side. Okay, was my face in the middle? No. Why is it an issue in this one? Because I need to go like this. Sorry guys, my face is a little rough. Maybe if I move it in the middle? Let's go with that. Find out. See how it works. Again, altitude is blue. Angle's green, median's red, perpendicular's yellow. Start with blue. Altitudes have right angles, so I either have D to E or I have FC, but my altitude has to go to a vertex, so it has to be the second one. Angle bisector has to cut an angle in half. Okay. So it's got to be that guy. My median has to go from an angle and cut the opposite side in half. So the only other thing going from an angle is C to G. And if you notice, it says A to G is equal to G to B. So those two are equal. So he actually does get colored red. And then my last one, perpendicular bisector, cuts the other side in half. From a side to another side, cuts it in half. All right, altitude again has to go from an angle, so it can't be this one. It's going to be on the outside this time. Angle bisector, well, angle B gets cut. Median has to go from an angle to a side opposite. It's got to be D. And then perpendicular bisector, side to a side, cuts it in half, so that has to be E. Ah, too much. Okay, blue and green and red and yellow. Sorry, there just feels like there's something hanging out on my shirt and it's very uncomfortable. So altitude creates right angles, but it has to go from an angle, so it's not this one, it has to be from C to F. Angle bisector cuts an angle in half. That's the only angle cut in half. The median has to cut a side in half. So what's the only side with tick marks? So it says A to D and C to B. So it could be this one, but the median has to go from an angle, so it actually has to be this guy. And then my perpendicular bisector cuts my sides in half. Altitude has to create a right angle, so it's either G or C, but it has to come from a vertex. So it has to be this one. Angle bisector cuts an angle in half. Median has to cut a side in half. So it has to be this one because it has to come from an angle. And then my bisector cuts my side in half from one side to another side. Now my face is in the way. Can I move this? No. Sorry, trying to figure out the best way to help you guys with this one so that my face is not in the way. I guess that'll work. All right, in triangle GHK, point T is the centroid. Determine the following lengths. Need my pen. So, if G to T, maybe we'll do highlighter. I'm trying to figure out the best way to show this to you without, no, let's do, I guess we'll pen. G to T is 15. Find T to V and find G to V. So in the whole distance. So I need to find the green side before I can find the second one. So if he is a centroid, that means it's 2/3 the sides. So if I take that's half the size. I gotta find my paper. Hold on. I don't have my handy dandy definitions in front of me, which would make this life a lot easier, which is not here. There, she blows. And then she. Okay, so centroid. Centroid deals with medians. Goes to the midpoint of the opposite side, divides it into two congruent segments. So it can get the side in half and is 2/3 the distance from the vertex is the opposite side. This is only half. I'm not agreeing with what I have, but again, I haven't taught this in a while. To me, it should be not the answer I have. Well, if it's 2/3, I know. Okay, so it is 2/3. Figured it out. I'm just having a dumb moment. So the whole distance of 15 is 2/3 of the way. So that means theoretically, if I erase where I wrote my 15 and I chop this up again, I'd have 1/3, 1/3, and 1/3, correct? Well, if I take this guy, he's 2 compared to the 1, right? So he's twice the size. So I'm going to take that 15, I'm going to divide him in half, which gives me 7.5. So then to get to GV, oh, that's not what I wanted to do. To get to GV, then I'm going to have to, unfortunately, erase all my pretty colors. and take my 15 plus my 7.5, which gives me 22.5. That's what happens when you're not truly prepared. It's okay. I had to just go back and read a second. See, reading gives us answers. Okay, number 2. TW. Oh, let's not do blue. Let's do red. TW is 17. Find HT, which I believe is the top then. Yes. Find HT and then HW. So now this is the smaller half. So again, this is 1 part, this is 2 parts, so I'm going to multiply by 2. So 17, oops, that's my face. Can't even tell I wrote there because it was behind my face. So 17 times 2, which would give me 34. And then the whole distance of 34 plus 17 gives me a distance of 51. Oh, there's part of my 0.5. UK is 42. It wants to find UT, and KT. Well, if I take 42 and divide it by 3, it'll give me each section of a third, right? So I'm going to take him, divide by 3, and I get 14. So the smaller section of UT will be 14. And then if I take 14 times 2, that'll give me the bigger section, which is 28. And then you should check, does 14 plus 28 equal 42? And it does.